return mixture network and mass balance and the application of null space. You run it. Okay, I'll take it. Okay. So, and we found how many independent equations? 5. Yes, that's what. So somebody said that okay, if you could have taken the overall mass balance of the two units together or something, but eventually we're getting 5 independent algebraic equations. So that's the view. Even as a chemical engineer, when you go to a plant, you try out all the possible mass balances by taking 2 units, 3 units and all those things. And your job is to see how many independent algebraic equations, and that will determine to tell the plant engineer, okay, these are number of degrees of freedom and these are these many variables you need to supply to me to get the unique solution. So null space and the rank, they play a major role in chemical flow sheeting. So that's the way, when this type of concepts would have been there when you have been taught process calculation. So in that case, process calculation will be very interesting. The entire process calculations can be taught. When I teach in the class, I teach with rank and the null space basis. In that case, the entire course will be application. So process calculation, the unique application of null space and rank of the matrix. If we know that, entire process calculation will be very, very interesting. So next I was talking about the application of null space for the stoichiometry. So when you have the equation like H2 plus O2 equals to H2, it is not balanced, right? Now it is balanced. H2 plus O2 equals to O2. So if you look at this equation, this is the H2, the coefficient of H2, new H2, if I say minus 2, coefficient of O2 is minus 1 and coefficient of H2 is plus 2, because these products are the reactants. Okay, new are the coefficients. Okay, new are the coefficients. So essentially in algebraic format, you can write this equation as an algebra. I should write this way, because as I said, product is plus and reactants are negative, are having minus sign. Okay? This algebra, this is not the concept wise in chemical reactions we talk about. Chemical reaction always talks about the reactions talk about the reactants and the product. Reactants talk about the reactant and the product. Okay. Now the thing is that if you look at, this is the stoichiometrically balanced equation, right? That means 4 hydrogen, 2 oxygen, 2 oxygen. If you have this equation, you can see the total number of hydrogen is 0, total number of oxygen is 0. Okay? So whatever mass is being generated, being absorbed. So there could not be any extra mass. Okay? If there is a reaction and the reaction, there is a reactant, a product, there could not be any extra mass. And that's the way. Whatever hydrogen is actually, they are the reactant. There is a complete reaction. If you consume as a product. Complete reaction of assuming. So remember that when we do chemical reaction engineering, there is something called conversion in the reaction. I'm assuming that complete reaction is fully completed and entire reactants actually are being consumed as well. Okay. If we assume something else, these are not valid. So if you look at hydrogen balance, the number of, so if I say number of moles of hydrogen is NH2, number of and in that case how much moles are actually there of hydrogen, how much atoms are there? 4 hydrogen atoms, right? Okay, 4 hydrogen atoms plus 4 hydrogen atom equals to 0, and of course NH2 is plus and NH2 is minus 2. So if you do that, so this is something called as atom balance. There's something called as atom balance. Okay. So NH2 is minus 2. Okay. So that's the way the concepts actually are. I'll be talking much on much on this aspect, and let's see that how the reaction mechanisms can be derived. So we have in a reactor, we have CH3OH, O2, CO2 and H2. CH3OH, O2, CO2, H2. A reactor. We don't know what are the reactants, what are the products. Okay, inside a reactor, or you can say some of the reactants, some of the products, we don't know. But in a reactor, we found that CH3OH, O2, CO2 and H2. Or not even reactor, we just say that in a chemical reaction, which of the species occurring, these species occur. Question is, find the reaction to this stoichiometric balance. Find the reaction or reactions. So first example, I give only one single reaction, and second example, I give two reactions. It may so happen that you can have two reactions, and that occurs in chemical reaction. 2-3 reactions can occur, right? We have seen it. Chemical reaction, chemical kinetics, we have seen 2-3 reactions are occurring, right? Yes. So if you look at, we have NCH3OH, you have to make it balanced, NO2, NCO2, and NH2O, number of moles of CH3OH. So we need to have the balance. That means our objective is what? NCH3OH, CH3OH. This kind of stoichiometric equation. NO2, O2. NCO2, CO2. NH2O, H2O equals to 0. This is the adjective format I am talking about. Some would be positive, some would be negative. Some has to be positive, some has to be negative. Otherwise, you cannot have chemical reaction. Some has to be positive like this. Here NH2 equal to -2, NO2 is -1, NH2O is +2. Similarly, we have to find out these coefficients. So here we need to find out the vector NCH3OH, NO2, NCO2, NH2. This is my X vector. This is my X vector. This is very important part I am teaching actually here in the class because it's directly linked with chemical reaction here. And that's why we apply mathematics and now sports. So we have to find out N6H3OH, NO2, NCO2, and NH2. Now, what are the species atoms you can see in the board? Carbon, hydrogen, and oxygen. There are only 3 atoms. That means we can get how many atom balance equations? 3 atom balance equations. So you can have C balance, we can have H balance, we can have O balance. Atomic C balance, atomic hydrogen balance, atomic oxygen balance. C balance, CH3OH, how many atoms are there carbon? 1 atom. 1 into CHN, CH3OH. Okay. Oxygen 0, right? 0 dot NO2 plus NCO2. How many are there? 1, right? NCO2 plus 0 NH2O. Am I correct? Equals to 0. Because as we have seen here, we are talking in terms of algebraic format, and the entire system, no extra carbon should be there. Whatever reactants supplying complete conversion, the product will take it out. If you talk about overall reactant and product, there is no extra, nothing. Mass will not be there extra. In a reacting system, complete conversion is whatever mass I am giving, it is converted. Okay. So if we talk about reactant and product, there is no example. Hydrogen balance equation, please tell me. 4 NCH3OH plus 0 NO2 plus 0 NCO2 plus 2NH2O equals to 0. Right? O balance 1 NCH3OH plus 2 NO2 plus 2 NCO2 plus 1 NH2O equals to 0. From here, what kind of equation you are getting? From here, you are getting AX equals to 0. Am I correct? What is that? 1, 0, 1, 0, 4, 0, 0, 2, 1, 2, 2, 1. NCH3OH, NO2, NCO2, NH2O equals to 0, 0, 0. As we know that, based on the, so this solution will belong to the null space. The solution will belong to null space. Now we have to see how many independent balance are this independent. Sometimes the atomic balance sometimes may not be independent. For example, if you talk about air, how much percentage of oxygen? 79%. Nitrogen is 21%. So in that case, if I specify oxygen, nitrogen is automatically found out. So oxygen and nitrogen, they are not independent air. So if we cannot say all the time atomic balances are independent. It could be dependent, and air is the classic example, right? Okay. So next step, you have to make echelon form and see that how many independent atomic balances. What's the next step for echelon form? What is that? R2 1 equals to R2 minus 4R1, and then R3 1, R3 minus R1. Very good. 1 0 1 0. Next is 0 0, then minus 4, then NCH3OH, NO2, NCO2, NH2. 0 0 0 0. Okay. Next step, what you get? So if you can look at this, you can do one more step, but it won't give anything. Okay? You can actually, what you can do, you can swap. If you have to swap, there is no other way. You have to swap, there is no other way, because you cannot divide by 0. That is called pivot. If you pivot, it is quite obvious that it is all are independent. So our atomic mass balances, they are independent based on the echelon form. Okay? How many unknowns we have? There are 4 unknowns. Okay? How many independent algebraic equations? 3. How many variables you have to fix by yourself? What is dimension of null space then? We have done last class. Dimension of null space? 1. How many independent algebraic equations will be there? No, sorry. How many reactions will be there? Only 1. We will show that. So here we will conclude something and we will actually show dimension of null space. We give independent number of independent chemical reactions. Let's look at my conclusion. So my conclusion is dimension of null space is number of independent chemical reactions. Okay. So what I will do that, I will assume NH2O equals to alpha. I'll assume NH2 equals to alpha. If I do that, can you tell me the answer? You know now how to calculate other values. So 3 independent algebraic, so if I fix it, so with 3 unknowns and 3 algebraic equations you can solve it, right? If we fix it, we can take this equation to solve. It's better or else. This system. If you look at the last equation, what you are getting? 2NO2 plus NCO2 plus NH2 equal to 0. NH2 equals to alpha, right? So what you got? 2NCO2 plus, 2NO2 plus NCO2 equals to minus alpha, right? Am I correct? So you got 2NO2, 2NCO2 equals to minus alpha. Am I correct? Next is second equation, how much? Minus 4 NCO2 plus 2NH2O equals to 0. Okay. From these two equations, and 2NH2 equals to, which is alpha, right? So NCO2 equals to minus half alpha, right? NCO2 is half alpha. Then what else you can get? Can you get NO2? NO2 is how much? Minus 3 by 4 alpha. Next is NCH3OH. Minus alpha by 2. So what is my null space basis? Only one basis you will get in terms of alpha. Of course, basically infinite, but we can set up one basis which is x vector, which is what? Alpha should be here. First is minus half, second is minus 3 by 4. Am I correct? NCO2 is plus half. Am I correct? Okay. So this is your vector, and I am assuming alpha equals to 2 to get the reaction mechanism. If alpha equal to 2, x bar equals to, alpha could be 1 also. You eventually have to do by 2 because you have to get reaction mechanism. So what do you get from here? So my reaction mechanism is NCH3OH, CH3OH plus, what is the reaction mechanism? NO2, O2 plus NCO2, CO2 plus NH2O, H2O equals to 0. Next step, minus CH3OH minus 3 by 2 O2 plus half CO2 plus H2O equals to 0. So these are the products, these are the reactants. So my final equation is CH3OH plus, what is that? Okay. This will be 2, right? Correct? I should not put an arrow here. It is stoichiometrically balanced. We have seen that we have derived the reaction mechanism. Yes, what's the problem? Why pausing? Who is having problem? If any problem your friend may not be able to answer, I can answer. Don't say your friend is smart. Any question here? So now you can see that how null space is useful to get the reaction mechanism. Right? How null space is useful to get reaction mechanism. Right? Or not clear? Understood any question? I will be asking you to give the notes here because I don't have any proper notes for this. whatever I am teaching in the chemical atom matrix. Maybe tomorrow you can solve it. Next is, shall I go for the, it is slightly complicated. So you can have, so this concept you can actually use for 1000 chemical species. So now we are actually pretty smart. Mathematically you can find the chemical reaction. So chemists will talk about that stoichiometry. We will say, okay, I don't require to know chemistry. Without knowing chemistry, I can derive chemical reaction. Beautiful, right? Because person like me who actually I don't like chemistry. If I see chemistry, I run away. I still remember that when I got chemical engineering based on my JEE rank. My JEE rank was not that good to get electrical or computer science or mechanical engineering. So I had to go to chemical engineering. And in my first 2 years I was crying on it. And because first course actually I was not happy with introduction to chemical engineering. I saw a lot of industries, paints, soaps and all those things I saw. Because I always used to like mathematics. And then when I told you that when I studied process calculation, I was completely frustrated. I thought there is no future of mine. But because I never liked chemistry. If I see chemistry, I don't know. This is the subject actually, I don't know, I should not say I'm hating, but this is a subject I get fever if I see. And now and at the end, when I see that chemistry, this kind of reaction has so much of mathematical foundation, I feel so happy. Because I understand now, mathematics is at every corner of life. And these are the corner of the class examples. Okay? Now I will show you another one complicated example. Okay. So let's look at determine the reaction mechanism. Determine the reaction mechanism and independent number of reactions. Determine the reaction mechanism and independent number of reactions for the species in a reactor. H2, CH4, CO, CH3OH, H2. We don't know which are the reactants to the products. We don't know which are the reactants to the products. The species are H2, CH4, CO, CH3OH and H2. 5 species. And my guess is there could be more than one reaction. Okay? And of course, the basis of null space will give the reaction mechanism. Here we had one basis. You could have 3 bases or 4 bases. Based on that, based on number of bases, we can have independent number of chemical reactions. Because the solution space belongs to null space, and which is basically obtained by Ax equal to 0. So my unknown vector X bar, which is NH2, NCH4, NCO, NCH3OH, NH2. This is my unknown vector. What are the species? What are the species available? Atoms, atomic species, C balance, H balance, O balance. So we'll first write H balance for a change. H balance, C balance, and O balance. Okay, we will volunteer H balance. So first we talk about H balance. Who will talk about H balance? Yes, sir. This is the way if I talk, you will be happy. I can talk like this, 2201 something, you will be happy. Did I teach that way? Of course not. I can do that way, you will be happy. So you cannot do that. Next, who can do the species balance, atomic balance? I forgot your name actually. Huh? Vasudha. Vasudha, okay, fine. Okay, can you tell H balance? 2? Yes, this is the way you talk. Yes, next. 4 into NCH4. 0 into NCO. Exactly correct. Next. 4 into NCH3OH. Very good. 2 into NH2O. Excellent. You want to continue? C balance? Yeah, you can do that. Go ahead.
1 into NCH4.
No, 0 into NH2. 0 into NH2. 1 into NCH4.
1 into NCO.
1 into NCH3OH. 0 into NH2O equals to 0. O balance remaining. Next. 0 into NH2. 0 into NCH4, yes. 1 into NCO. 1 into NCH3OH. Plus 1 into NH2 equals to 0. Sorry. X equals to 0. What do you get? 2, 4, 0, 4, 2, 0, 1, 1, 1, 0, 0, 0, 1, 1, 1. The next vector is NH2, NCH4, NCO, NCH3OH, NH2 equals to 0. You can see that automatically that 0. So I made the problem much easier. So in this problem, it looks like you cannot do anything. Already in echelon form. This problem is already in echelon form. How many independent algebraic equations? So it says that there are 3 independent atomic species balances. There are 5 variables. Okay. Dimension of null space 2. Dimension of null space is 2. That means how many independent chemical reactions will be there? I told you that. Dimension of null space is number of independent chemical reactions. So there are 2 independent chemical reactions. So dimension of null space equals to 2. So we have 5 unknowns and 3 equations. So we'll actually NH2O you will write as alpha and NCH3OH you write as beta. That is the way you check the null space, right? You do null space. That is the way you do null space. NH2 equals to alpha and NCH3OH equals to beta. Right? So your job is to give me the answer of X vector in terms of null space. Alpha I want plus beta I want. What are your answers? What are your answers? X vector alpha into something plus beta into something. What are your answers? Any answer from your side? Any response from your side? How much you got in NCO? NCO is minus alpha minus beta, yes. And this thing NCH4 plus alpha. And N first is NH2. Okay, then construct everything you got. Then what's the problem? Yes, madam. No, just I want these numbers. Minus 3, 1, minus 1, 0, 1. Next. Minus 2, 0, minus 1, 1, 0. So this X vector is nothing but NH2, NCH4, NCO, NCH3, NH2. So what is the reaction? First reaction, first independent reaction, tell me quickly. Now you know these are reactants and these are the products. So there are 2 reactants, 2 products. Here what we have, there are 2 reactants and 1 product. You can see from here, There are two reactants on two product. Here there are two reactants, one product because negative side. Correct? Okay. Independent chemical reactions quickly. Who will give me the reaction mechanism? First one is CO plus 3H2 equals to CH4 plus H2O. Next is CO plus 2H2 equals to CH3OH. Two independent chemical reactions. So you don't have to know chemistry. So if you are really in my position that you don't want to do any. In fact, I wish I should have known these things in my 9th or 10th level. In that case, all this reaction mechanism, all those things, in organic chemistry you can actually get secured because this reaction mechanism you can do. If the species are actually known, you do this analysis, you get the reaction mechanism. Okay? We struggle quite a lot. Sometimes we mug it out. And remember, sometimes we mug it out. We don't have to mug it out. Right? Is that technique is that? Right? So with that, I think I have done enough of the null space, range space. We have seen the application of null space, range space, and rank in chemical engineering. Every aspect of chemical engineering, this has enormous amount of application. And quite often we talk about Ax equals to 0. We'll say, okay, Ax equals to 0 just like for mathematical way. Why to solve Ax equals to 0? We solve for Ax equals to b. But we found that Ax equals to 0 has tremendous impact in chemical engineering. And those are the examples I have addressed. Now I will be formally starting vector space. Okay, so before going to the vector space, I will talk some of the, first I will talk about the scalar quantities. First we will talk about scalar quantities and what are the properties. Scalar means you know that's numbers. The numbers are called as scalar. Okay, any numbers 1, 2.5, 3.5, 4, 5, anything. It could be real number, it could be complex number. Complex number is 5 plus 6i for example. So before getting into the vector space, it's better to talk about the properties. So first property is commutative property, which is having addition a plus b equals to b plus a. What are scalar quantities? Multiplication, which is having ab equals to b. Okay. We have associative property. So first property. Second is associative property. We have addition a plus b plus c, which is a plus b plus c. We have multiplication, which is a b c equals to a into b c. We have distributive property. Which is a into b plus c, ab plus ac. We have density property. Which is between any two real numbers, there is always another real number at least. That is called density property. Between two any real numbers, there is always another real number at least. And next is identity property. Identity property, which is addition a plus c equals to a, and multiplication A into 1 equals to A. Right? So we have commutative property, associative property, distributive property, density property, and additive property. So these are the properties, and we'll see how these properties will change for the vector space. So now we are slowly entering the vector space. We have seen the vectors, and but we will see now formally how these things can be addressed. So when we talk about, we have seen Ax equals to BRT. This belongs to vector. Vector space, this also, this matrices. When we talk about the vector x bar, x1, x2, xn, this is called as n-dimensional vector. 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 Sometimes you have a two-dimensional vector, which you can see represented in the graph paper, which is x1 and x2. And this x1, x2, xn we can represent by number of modes. For example, we have so many species, reactants or products. We can represent them as n-dimensional vector, what we have seen just now. So that's what chemical reaction is such a subject where we can find easily the example of n-dimensional vector. Okay, and just now we have seen that one. So how the vector space is formed? So we talk about the numbers. When you talk about scalar quantities, you can say this is space. Numbers are 1, 2, 3, 4, 4.5, 3.7, 9.5, 1000, 995.7, anything. You can say pick up the number, the scalar quantities. Okay? Any number is scalar quantity, and for those numbers, any two numbers you take, these are the properties you vary, which are the scalar quantities. And quite often, this space of real numbers I call as numeric field. I call this as numeric field. I call this as numeric field, and mathematically this can be represented as K. Remember that there are two vertical lines. This is the way mathematicians represent, and you also have to represent. I ask so many mathematicians why you are putting this. Or for real space, sometimes they put like this. You might have seen the books. Okay? I don't know why these other vertical lines actually be done, but they say that if you put R, that is an alphabet. If you put this double, this means we are talking about mathematics. Okay, accept. Because I don't know the answer, so I have to ask mathematicians. And they told that okay, if you put on one vertical line and R, this is the alphabet, and this is for the real space. This is for the numeric, which is K, which is have a vertical line. Okay. So, before defining vector space, we need to have the numeric field which consists of the numbers, real numbers. Okay? And we have seen what are the real numbers and what are the properties. So once we know the numbers are not that these numbers are difficult. You know, an entire number theory has been is there, and by our great mathematician, Dr. Ramanujan. He actually invented, he worked on the number theory, and so much things actually have come. So looks like numbers are very easy, but they are not. So they are really very complicated. So when the numbers are actually defined, it is now right time to define the vector space. Please write down the definition of the vector space. A vector space over the numeric field, capital K, where capital K could be equals to R, real space, or capital K could be equals to the complex space. Complex also vertical line C, vertical line, complex. So K could be equals to R or could be C. So vector space over the numeric field K is a non-empty set capital V non-empty set capital V, comma, whose elements are called vectors, comma, whose elements are called vectors, and in which two operations are defined, called addition and scalar multiplication. Let me repeat once again. A vector space over the numeric field capital K is a non-empty set capital V, comma, whose elements are called vectors and in which two operations are defined, comma, called addition and scalar multiplication, comma, that enjoy the following properties. A vector space over the numeric field capital K is a non-empty set V, whose elements are called vectors and in which two operations are defined for addition and scalar multiplications that enjoy the following properties. So, what are the properties? So, we will just compare the properties of scalar quantities and the vector space, and vector space is born from the numeric field which has the scalar quantities. That's pretty interesting. So, let's look at the properties. Number one, addition is commutative and associative. Addition is commutative and associative. There exists an element 0 belongs to capital B, which is called vector space, which belongs to capital B is called belongs to, which is called a zero vector. Sometimes we write zero vector or we can write zero. Okay, this is called zero vector or we can call null vector, such that any vector V bar plus 0 will be V bar, where V bar belongs to capital B, where V bar belongs to capital B, where V bar belongs to capital B. Right? Correct? So V bar, so this is a numeric field. So there you can actually draw a vector space where say maybe two-dimensional vectors are 1, 2, 3, 4, say 2.5, 300, like that. All vectors are actually moving around. They are not moving around, just they are there. Just saying. So from the vectors, you can also have null vector 0, 0. Okay, any vector, if you just add with the null vector, you get the same vector. That's a mathematical representation. This also belongs to capital B. This also belongs to capital B. For example, 3 belongs to capital K, numeric field. Capital K is numeric field. This is scalar quantity. So any scalar quantity will belong to numeric field, capital K. Okay. Next property. 0 dot V bar equals to 0. 1 dot V bar equals to V bar, where 0 and 1 are scalar quantities and they belongs to capital. 0 is 0 is the null vector and 1 is the unit vector. Unit vector is a vector which has physical length unity. We have learned it in 10 plus 2 physics. A vector whose physical length is unity. For each element, V belongs to capital B. There exists minus B, which is vector where minus B belongs to capital B. We have taught us like that, such that B minus B 0. Next is the following distributive property. The following distributive property. We have seen distributive property. Let's see what are distributive properties scalar quantity. A into B plus C equals to AB plus AC, right? Where A and B and C are the numbers which belong to a capital K. Here we have distributive property between scalar quantity and the vectors. Second bench is sleeping. You are a very smart guy to sleep. I should learn from you how to sleep in the class. Very steady sleep. I really appreciate. And maybe I hope that I have a separate iPad to see the record how people sleep in different fashion, which I really want to learn. Because I also attend different meetings, and if I can sleep you like you, it will be really extra. I won't be caught. That's good. I appreciate your way of sleeping. Alpha belongs to numeric field. Alpha belongs to numeric field. Okay? What you need? A into B plus C equals to AB plus AC, right? Okay? So I want to replace A by alpha in that. You look at it as distributive property in the scalar quantity. So B and C I am adding, and B and C must be vectors. I cannot add scalar and vector. So I can have two vectors, V and W, which belongs to vector space. Alpha belongs to numeric field. Okay, my distributive property will be then, you tell me. What is my distributive property? You know the scalar quantity distributive property I have just now told. Alpha into V plus W equals to alpha V plus alpha W. Right? So almost same, similar kind of property you can actually have, and similarly you can have two scalar quantities and one vector. That is also possible. So there are two ways we can go. So we can have another scalar quantity beta which belongs to numeric field. Then if we have one single vector V bar which is having alpha plus beta, we can write alpha V bar beta. These all properties we can actually draw by the triangular way, triangle rule of vectors. This is V vector, this is W vector, this is W vector, and this is V plus W, right? So now I am multiplying, I am increasing by alpha V. Similarly, I will increase by alpha W, alpha V, and it has to be alpha V plus W. How can you prove that? How can you prove that? Some famous rule of geometry is there, or trigonometry is there. If I increase by alpha V and increase up to alpha W, how can you prove that? It will be alpha V plus W. Resultant. What property of triangle? Symmetry. Symmetricity of a triangle, you can prove that. So both ways. There is a mathematical way, and so every property of the vector space we should be able to prove in a geometrical form. Thanks for your kind attention.